Welcome to Factorio. My name is Nilaus, and this is a showcase of a work in progress that I'm working on over on Twitch. It is on every Sunday at 8 p.m. Central European Time. I am working on a self-expanding base, and this video is serving two purposes: get you interested in this project, so maybe you'll come on over and join and be part of the design and debugging over on Twitch. It also serves the purpose of getting anyone up to date if you have missed some of the streams and would like to know how it works, so I don't have to spend an hour going through it every stream, because it's getting kind of complicated. So this will serve as a bit of a primer on how I'm going to build this. The idea is that I will be approaching this as a major IT project. I'm going to be breaking it down into deliverables, into minimum viable products. I'm going to be de-scoping things, both for short and for long term, and just managing the constraints so that we can get something done in each stream, a small sprint, you could say, and I think it's an interesting approach, and it's been working so really well so far. So what I'm going to do in this video is show you how you can actually do the main two functions of a self-expanding base, and it takes a remarkably small amount of the stuff. Here, this part is one part of it, and what here is another part of it. And I will be trying to explain in this video how they work together. So stay tuned. Hope if you, of course, enjoy this kind of thing, and this is exactly the kind of Factorio stuff you want, you are interested in, then hit the like button, leave some comments below, come join the live streams to be part of the design process. Some of these algorithms are directly copied from community contributions, and some are heavily inspired by community contributions as well. So it's definitely a community effort, this part. Now, this is by no means completed, but it is a little bit of a start. And I think the best way to explain it is just to get it started, just to show you what it does. The core of it is a blueprint book that we have here. It doesn't have any real blueprints. It's just placeholder blueprints. Only one of them has been just drafted at this point, but all the other ones are placeholder blueprints. So I'm going to be using placeholder blueprints at this moment. And the way that it starts is that we are going to have to go really, really close to this part, and then go into this box, and I'm going to put in here. I'm going to explain this one. This is the main loop that determines the cadence of building another city block, because of course it's going to be city blocks. It's really hard to make a self-expanding base without using city blocks. Then over on this side, this is going to be sort of what I would call the main function. There will be one of these code elements, functions, you could say, and for each of the city blocks. So basically it'll identify. I'm going to use, it's basically going to function as a, you could say, as a for loop here, where it goes through, and this little token here is moving on the belt, and that ensures that it's only going in, it's then either going into this function or it's not. And then going on to more and more functions, and it is designed in a way that all I need to do is simply add another one down here, change some conditions, and then it actually does that. So we are going to just let this one flow on the belt. You can see it goes in here, and now green means it's available, yellow means it's currently working on it, and red means that it is currently blocked. And then you can see over here, this one is working as well. And what has happened in the meantime is that one city block additionally has been placed up here. It is going to be expanding in a spiral pattern, and we should be seeing the next one coming out shortly. And here's the next one being placed. And my robots, they're a little bit quick, so they already built it. The spiral pattern will work that this is our default starting, and then it'll go up here and around, and then keep doing in a spiral pattern. That algorithm for defining the spiral pattern is here. It's made by Extra Trading Space user on Twitch, who made this cool thing that identifies the coordinates, X and Y coordinates, for each of these, sort of relative to one. This is 0 by 0, and then it goes all the way up here. You can see the next one is being added right now. And then I'm going to leave this running as we continue with the explanation. So now I'm going to dive into each of the functions, how they work, so that we get a part of it. There are three components of this one that are working together. The way that it works is that I will have a main loop. This is the main loop that controls when and where a new city block is placed. And then I will have, this is the function. I'm calling this the deployer. This is the function. And the function will identify when we have multiple. We currently only have one because I'm working on this one still. This one will determine what is being deployed. It's either going to be, in this case, copper, or it'll be another one down the line when we add that. And then the third one is sort of the network, and that network is basically the rest of the base informing back to this location that it is what it's actually working on. And I'm in order to do an analogy, I would say this is the heart of the whole thing. This determines the heartbeat, keeps the whole thing pumping. This is the brain of the operation, deciding what to do. And then you could say the central nervous system is the entirety of the base, sending information back through the wire network to the function, to the brain, to determine what to do. And the heartbeat determines the pace of building it. And then you can say the base is actually the skeleton and the body of this beast here. Let's jump into the main deployer. Now, this may be changed later on, but it functions in a certain way. I'm using one specific mod. There are a few mods here, but none that really change much in terms of features. The only one that is a radical change is this one, the Blueprint deployer. It's a remarkably simple one. It's called Recursive Blueprint. What it does is, if you place a blueprint here, and then you can give it some commands, some variables, then it will deploy that blueprint at that location relative to this one. So it basically means I can set up an X and Y coordinate, and then it will be deployed there. I can give it a command in terms of the what blueprint in here it will deploy. You can see there are many blueprints. I can send a command which one it is it's going to deploy. So we basically have one book, and then it's going to be getting the command in to say deploy blueprint number 7 or 22 or whatever, and that's the one that gets deployed. There are a number of conditions, as you can see here. I'm also using a little text one to sort of have hover over. We can then get information. This is basically the comments in the code, and basically you can see that it loops around here. Let me go through each of the conditions then so we can explain it. This one is the trigger a new city block. So when will it trigger? Well, it will trigger when the construction bot signals is equal to the blueprint being deployed. What does that mean? That means when it gets an input on the red wire that has a construction bot signal, that means a signal of a construction bot. And that is the trigger, according to the mod, of what blueprint to be deployed. And then once that is true, this one activates. You can see it activates when the construction icon here is greater than 0. Now, if you're not familiar with circuit networks, this is all going to be mumbo jumbo, but it can still be very enjoyable to watch as we build and debug and stuff. But it's mainly for, let's say, advanced users. So that means this one is when it's here, it will be pushed in when there is a signal, and that signal comes from the function what to deploy. Now, the other one here, this one doesn't have any condition, because as soon as it goes in, it'll hit the deploy, it'll stamp down the blueprint, and then get it out. So why do I have this weird thing? Well, I'm having this condition here that says, let's actually just hover over it. It says when available bots is less than total bots. This means that it goes out here, and then I want to make sure that robots are actually flying out. When we build a new block, you can see how quick they're actually being built at this point, because there's nothing in them. Then here you want to see that the robots are actually busy, and then it goes to idle. Once it goes idle, that means these numbers are equal, then it will allow it to pass on. No, when it's less than, when the robots are busy, then it allows it to pass on. When the robots are idle again, then it will start a new loop, because when it's idle, it allows it to start a new loop. I also use these conditions as input for other things. For example, here I am reading the hand content. The hand content will of course be the blueprint book. I get that over here. This is going to send a green signal. The green signal is going up to this code part, this function, which will then increment this whole function to tell me where is the next one going to be placed, because you have to sort of go up, and then from here go one up, and then go this way and this way and this way. And that's a little bit complicated. That's what this code does. Not going to go through it. As usual, I should mention that if you are a patron supporter of the channel, then you can grab the save game, and you can start messing around with it yourself if you feel so inclined. I am also here. This is identify condition to exit the function and go back to the main loop. Yes, this is another part, because when we go into the main function here, then I want it to be stuck in here until the robots are idle again. So I basically want the flow to be identify what to build, then build it. When it is done building it, restart the cycle, and then loop back here, find out what is necessary in the base, build that one as well. So that is basically at the end of this. This will send it out as a yellow signal. The yellow signal will be a signal from the deployer back to the function to say, please return to the main loop, so it can start building another one. Then this part is to reset the blueprint that was just deployed, because I'm getting a signal in here. Let's actually try hovering and then over to right hand side. There we go. We got a signal of 8, and that gets reset again. So this one just makes sure that it gets reset, so that I don't I don't accidentally just pollute the numbers. And it's basically resetting that variable so that it's empty now. So that is the deploy function explained. It seems really simple. Basically what, and the last thing is the interaction with this. I get out of this function here, I get these coordinates 3 and 2. That will go in here and get multiplied by 100, multiplied by minus 100, then added the offset. The offset corresponds to from this location down to that location, which is where the Nuix blueprint will then be stamped, and then that is basically just sort of expanding it out to fit the city block pattern. Now let's move over to the function. Now I will have one of these functions for every single city block, and it's a lot of repeated, so I'm kind of looking at whether I can do it in just having one of these functions, but I don't mind copying this 20 times and just having it, because I also like the idea. I've decided, instead of using circuits, to actually use sort of an analog means here, and also more of a Factorio-esque a way where we actually have a token moving on a belt, because the token on a belt is pretty good at illustrating that the function can only be doing one thing at a time, and you really control it here. It will just add a little bit of lag, but that's not a problem. Now the interesting thing is, this is remarkably simple. Look at the spaghetti, but that's because most of it is actually a supporting function. Basically what I am simulating here is that there is a demand. These are global parameters. The T, will come back to that, but then it's saying that please make one iron city block and one copper city block. Now, of course, since we don't actually build it, this is just simulated and have a constant demand. That's why it keeps building the same one. Then it comes in on the green wire. That's a value on the green wire. Basically, the green wire is information from the network and the deployer to the function, while the red wire is information from the function here back to the network and to the deployer. That's kind of how I'm keeping them, the global red and green network, so that I keep sort of directionality of where the information flows. Now I'm going to get the green wire. It's going to go in here. This combinator is simply just making sure that we get everything in, and anything that goes on into this function doesn't leak out. So making sure that things stay in a local scope here. And that goes up to this, which is powering all of it and also moving on. Then basically the next thing it goes in here, and then basically says, hey, if you are receiving a copper plate, then send an activation icon. So it's basically, if copper is needed, bring it up. If iron is needed, let's say we have another one down here that's for iron, then, or for all the other stuff, then it will just pick up the first one that's active, which means there's a certain amount of priority. I'm just going to go over to have a look at this one. You can see it'll also be prioritizing from the top, getting a power, smelting, intermediates, circuits, and it disappeared again. It'll come back. There we go. It's back again here. And then science at the very end. That's kind of also going to function as a priority here, and we can then implicitly make the priority. In this case, just having one, because we're working on it, it'll show the case. So what it does is basically say, hey, if there's a copper demand, activate it. This one actually has 2 activation icons, and we'll go back to the other one. So this is basically one, and then the other one is the reason why it's still flowing around here, even though it's active. The green one indicates that yes, we would like to build it. Then the only thing it actually does is take and says, if copper, then deploy blueprint number 8. Blueprint number 8 goes in here. This one basically just identifies that, whoops, we have now picked it up from, it's now in this box. Then it sends the signal back on the red wire all the way back in here, and that's the trigger to start the next deployment. So when it goes into a function, it deploys the function immediately. When it's yellow, that means it's waiting. It is currently in the process of building that city block. This is very short here because I have super robot and that doesn't really build much, but that could be easily be like 2, 3, 4 minutes of just robot flying back and forth, building a new city block. Also with more travel time, it'll be taking longer and longer, but it basically go here. And then it'll get a signal coming from the deployer when the robots are idle. When the robots are idle, it'll get a yellow signal, which is the indicator here to move from the storage box to the output box. It moves over here, and then when is it exporting out? It just exports out immediately. What you can see here, it exports back to the return loop. So this means that if it makes copper, then it goes back in here and then it'll try copper again. It won't sort of progress downwards, because if it progressed downwards, it would go like 1 iron, 1 copper, 1 stone bricks, 1 steel, so on and so forth, all the way up to 1 rocket silo. And we don't want to build a rocket silo at this point, because that's kind of the last thing we want to do. We want to build up the base from the beginning, build the iron smelting, the copper smelting, and then the green circuits, and then so add more and more stuff as we progress upwards in the tech tree. And this was why we are then resetting the loop and coming back. So if you've been thinking about it, you might think like, hold on, the issue with this is, as soon as they build a new city block for copper smelting, for example, it'll need to get some resources in on trains, but that's going to take a bit of time. So if it just flows back, it'll just build another copper, another copper, another copper, because I haven't saturated the demand yet. I haven't fulfilled the demand yet. It takes a while for the copper to come in, to be smelted, and then build up buffers in order to be satisfied. So I need to have a way to prevent it from just spamming the same one again. And I am using a taboo search algorithm for this, or basically making a taboo heuristic. And basically what that means, if you're not familiar with that part, is that I am basically saying, if you have built a copper, then you are not allowed to build a copper for the next T city blocks. T in this case, I've just set it to 5. And that is basically just a very, very simple way of saying, you even though you think you need more copper, then you are not allowed to do that. You have to build something else, or at least in this case, just run through the loop sufficient number of times in order for sort of enough time to pass to actually allow the copper to be saturated in the copper smelting location. It's a bit tricky to how to do it, but basically what I do is I monitor every time it passes through this, because it only passes through here. It won't pass through down further down the list if we also put something in taboo here. And then it basically goes from here into, well, this is the decider. The S is how many times it has passed by. When that is equal to or greater than the taboo list, the number of number of times it has to pass by without it actually going in, then it's actually allowing it to go out again with the blue signal going back here, and that's the second blue signal that needs it. So it will allow to pick up when it is no longer taboo and it is demanded from the network. So once those two conditions are true, then it'll go in, and of course I have to have a reset condition and all that stuff. And that's the red indicator here. The red indicator is an indicator that it is in taboo right now. So even though there is a constant demand for copper, I'm not building it because it's in taboo, and I need to sort of let it build something else. And by having this one, of course, it would sort of go down and go into a iron smelting, steel smelting, plastics, or whatever, all of that, until it goes into one of those. When it goes back, then it goes back and restarts again. So the earlier functions like copper and iron smelting will be more likely to be built, but that's also intentional because that's the main part. Also, you can see here I can use this as breakpoints. So I can just do this part, and then I have a breakpoint at a certain location. I think that's really clever to be able to make breakpoints by just manipulating belts. It also gives like a really easy way of seeing where we are. Of course, we're going to have these green indicators for all of the stuff that is happening, but we also have a little icon here moving on the belt, which I think is really nice. So I think this is absolutely amazing how simple it actually is. We're talking about 2 simple functions that it corresponds to. Like this little thing here is so damn simple. It's not simple, but it's few components, and that's good code, I think. It's it's not a gigantic mess of circuits. It's a really small thing that has a controlled loop based on idle states. This one is also pretty simple. It just basically identifies if there's a demand. If it's not in taboo, then deploy this one, and then it moves on. We have a million things that are not done, and I will just get into some of the constraints that are currently not available or not supported here. Obviously, I don't have a lot of city blocks. What I can do is I can just break this out here, and then I can change this to being here, and then I can change this to being 7, and then we allow that one to go in. It'll still have to pass by. There we go. And then you can see here now that is a proper build that we're building here. This is what you'd much more likely to see. Of course, not even as fast robots as this, but that will be a actual genuine city block that has demands inbound and demands outbound. And that's what we are now also going to start working on, making designs for these locations. And they are going to be really compact because it has to be in one city block. And I've decided the tech level is going to be blue science, so I can't just build things with yeah, I can't just do. I have to bring things in by train, or even the fuel here for the trains. They have to be brought in by another train. It's just a decision I have so that I can sort of say that this city block or this self-expander can start as soon as you have blue science, as soon as you have robots, construction robots. Then you can actually stamp this down and just have it work its way from there. Other constraints, as I was saying, I am currently, you can see here, there's no water, there's no cliffs, there's no resources. I'm just going to have infinite resources. That's again one of the ways I want to scope things. I'm just assuming that I have the resources. I'm using this mod here, Editor Extended, to just have infinite crafting materials available. I'm using these boxes here to have infinite resources available, and that's something that is very good to get the ball rolling on building something, because building an actual new design for identifying ore patches and mining and those ore patches, it's going to be difficult, and it's something that I'll have to spend a lot of time in the beginning, which means I'm not going to get on with the actual build of this the base. So this is something I've decided to descope for now, so that we get the main loop going, the main loop here and the main loop here, get that to some working degree, and then get some simple city blocks out here that we can then start working on, and then have sort of the selector, and then we can start adding more functions later on as well. I'd also really like, in the final form, I'd like to also have a hub. Of course, I'd like to have a hub so that you can actually have resources going into the hub to make sure that those demands are not coming from an infinite box, but actually being built and requested by the network in order for it to go out and become available to build the next one. And then of course making conditions so that we don't build another city block without having sufficient resources to actually build it. Those are all things that we need later on. Of course, also I'm having infinite power. Power is another important thing. We need to make sure that we build power to match the needs. But again, scoping it like a big IT project, we have to make something that we can show to our stakeholders. That's you, dear viewers, so that we can be allowed to do one more stream of this and progress. And I will be regularly coming back and doing more updates of this construction thing as we go a little bit further. If there's an interest in sort of having a random video here on YouTube explaining how it works in more detail as we progress. So with that, thank you very much for watching. I hope you enjoyed it. If you do, hit the like button. Let me know in the comment section. If you start coming up with complex ideas and how to improve it in the comment section, I'm gonna read it, but I'm not gonna react to it because it's just impossible. You can't code you can't give code reviews in a comment section. Well, you can, but it doesn't work for me. But come on over to Twitch or make a really cool blueprint and upload it to factoriobend.com and then share it in my Discord. Then we'll definitely have a look at it during the workshop sessions. Thank you for watching. Until next time, take care and stay effective.